when we talk about AI, in relation to us, we're not talking about a form of life versus another, one against the other, but rather a product generated by a form of life that is us. In other words, artificial intelligence exists because we exist and not the other way around, at least for now. And I repeat then, moreover, it seems that AI has jumped out of the hat from one year to the next, while many of our systems, our daily tools, have been using code, let's say, intelligent for some time now. In short, AI was already around us for quite some time now, and with an intelligence of a rational type, I would say, the one most similar to the cold and logical stereotype of the robot, that is that of an algorithm, that is of a finite specific sequence, or of instructions, of rules. Well, of course, this model of narrow, limited, purple artificial intelligence, a bit like the great scientific dream of a general AI capable of solving problems across all fields. However, in research, it was already noticed years ago that it was easier to program an AI focused on solving one or a few specific problems. And this happens through algorithms, that is, mathematical rules and formulas. While it's true that the dream of a more intelligent, more flexible artificial intelligence than that governed by algorithms has always been alive. So they started studying a form of AI that works a bit like our nervous system, like our neurons, which are cells that communicate with each other. And so we arrived at neural networks made up of many small computational nodes, as if they were single neurons connected in such a way that what one throws out, as a result, its output, becomes the input of the following node. This is also thanks to weights that, in this communication between nodes, determine the information that is given to the other node. Through this communication mechanism, from one to another, and with a certain weight, neural networks can learn on their own how to solve a problem and how it's machine learning, the learning of the machine. An English term that you may have already heard by now. How does this machine learning happen? First of all, there is a training phase where the machine learns certain things. For example, to distinguish between paintings by Van Gogh, Picasso, and Leonardo, and so on. You teach it by pointing out to the program the shapes, the colors used, certain recurring characteristics. In short, just like we learn to distinguish the styles of artists by eye. It's even easier if the styles are very different and distinctive. If the machine makes a mistake in distinguishing the paintings, for example, attributing a painting by Leonardo to Picasso, the machine uses an algorithm called backpropagation, which, let's say, goes back over its choices and adjusts the weights between communication nodes to reduce the chance of error. Which, if you think about it, isn't too strange, because this ability of the machine to learn from mistakes is a good step towards human intelligence, because we humans also learn through mechanisms of trials and errors. Let's also add as an additional note that the AI we currently see spreading. It has adopted a specific type of machine learning known as deep learning, which is capable of handling unstructured data, such as natural language or images. By structured data, what I mean is, for example, tabulated data, so organized in tables. Imagine Excel to understand it in a simple way. Now let's dive into how large language models work, which are the AI that are currently getting the most attention from the public, starting from the immersion of GPT-G.